Hello everyone, I am Soumya Ma'am, Assistant Professor of Civil Engineering at Vedang Institute of Technology. In our previous class, we have learned about how to draw influence line diagram for simply supported beam. So today in this class, we will discuss about to draw influence line diagram for cantilever beam. So let's start from drawing a cantilever beam. Okay. We know that cantilever beam is nothing but a beam in which one end is your fixed end and another end is your free end. Nothing will change here. So let's take the beam as AB and the length of the AB beam is let L. So we know that why we need to draw the influence line diagram in case we have a moving load at AB beam. So we can draw the influence line diagram. So let the moving load, that is unit load 1, is at a distance of x from point B. Okay. So what will happen next? We need to draw the first we will draw ILD for shear force at A, then ILD for movement at A. We need to find out these two things. So how to draw? We know that in case of a beam where the support stands, the reaction will come at that place. So here only at point A we will have the reaction. The load is applied here is 1. I can write that shear force at A is equals to 1. That is your constant. Okay. So next I can write ILD for shear force at A when the load changes its position. First we will change the loading position to from these to this. If the load 1 move from this point to this point. Okay, this yellow load is your moving load. So now what will change? The change will be when x equals to 0. If this distance becomes 0, then the load will apply here, right? If the loading changes, this constant will not change any position. So I can write that SF at A is equals to still 1. Again, if the loading changes from this to this position, so what can I write? I can write that when X equals to L, if this loading comes at this position, what will happen? The shear force will not change. I can write it as 1. So now let's draw the ILD for shear force at A. It can look like as the loading position is not changed anywhere, this will be your positive and this to this distance is your 1. Okay. Similarly, we'll go for ILD for movement at A. We know that how to find out movement? we can find out the movement by multiplying the shear force into distance. So here I can write that movement at A will become 1, that is, see, here we are taking the force in this direction, like anti-clockwise direction. Sorry, this is your clockwise direction. We know that when clockwise direction, that will be your negative sign. If the load moves anti-clockwise direction, that will be your positive sign. Whenever we are finding out the shear force bending moment or ILD diagram, we need to know this thing. If the load is acting clockwise direction, the clock moves right like this, na? So this will be negative. If the load moves in anti-clockwise direction in this way, or if we need to find out the moment at point B, so the load will act in what? Anti-clockwise direction, that is your positive. So here this is your what? Clockwise movement. So what we will do? First we will put one minus sign, then we will put the shear force value, and we know that shear force multiply with what? The distance. The distance is L minus X. See, if this is the X distance and this distance, the whole distance is L. So now we need this distance, that is your L minus X here. So that I can write MA equals to minus of L minus X. Now, when X equals to 0, so this movement will become MA equals to minus L. We will put the 0 value here. This L minus 0 is L. Now minus L. If or when X equals to L, this value that I can write here, L minus L is 0. Now you can see this X value changes from 0 to L, and here the value also changes. What? Minus L to 0. Let's draw the beam. Here is the cantilever beam AB. Let the length is L. Here the applied force, that is 1 at a distance of X. So you can write that L minus X. Okay. So to draw the movement diagram, this is your A, B. Here you can see movement at MA is minus L. When? When X equals to 0. So 0 at what point? At this point. X equals to 0 at this point. So this value is minus L. Let this is your minus L. Okay. Again, MA equals to 0 at what point? when x equals to L. Here x equals to L. This will be what? 0. So how to draw? Just need to draw this like, and you can write it here negative. We need to remember that ILD for movement will come in negative values. Okay. Now we know that the load 1 is moving. So now we will find out we will take a section and name it as C, and let the distance here is Z. First we will go for shear force at C. Previously we know that shear force is constant all over the section. So to find out shear force at C, what we will do? We will take two values when your x is less than Z. That means this x will, or this load will stay at that point. Okay. If x less than Z, here you can see when x equals to 0, the shear force is 1. Also here also shear force is 1. So now I can write that SF at C will be 1. Another thing is when x is greater than Z. X is greater than Z means the loading will be at this point. So now what will happen? The shear force will become 0. Okay, as at that point no force is applied, so shear force will become 0. So how to draw the ILD now? Here I can write that ILD for shear force at C. We'll draw this another line C, A and B. I can draw this. This is your 1 up to point C. From C to A, the shear force will be 0. Okay. So the very similar process. Now we will draw the movement at C. So we have a value that movement is minus L minus X. So now I can write if or when X is less than or equals to Z. If X is less than or equal to Z, so the movement here will become minus of Z minus X. Here one is here. Okay. Now when x is greater than z, if the force is acting or moving from this point to this point. That movement will become minus 1 z minus z, so that will be also 0. If we go for the ILD diagram, you can write that ILD for movement at C. If we go for the ILD diagram, you can see that when x is less than z, the movement becomes negative. Up to which point? Up to this point C. Okay. So, here the movement becomes 0. So, you can draw it like this. Let's join this, and the value is your minus of z minus x. This is your negative. Okay. When the load is moving from this point to left of the beam, then the diagram changes its sign from the section. Okay. So, here in this class we have drawn the ILD for shear force and bending moment for a cantilever beam by putting an unit load. So, in our next class we will solve the influence line diagram for overhanging beam. So, stay tuned. Thank you.